You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine a scenario where the actual code you write is the least valuable thing you do all day. A world where writing software is a low-cost commodity, and your real job is just verifying that a machine did not completely ruin your architecture.
Yeah, it is a massive recalibration of what an engineer actually does. I mean, we are watching the industry transition away from rewarding pure syntax memorization to rewarding pure system design.
Right, and the foundational value of a developer is no longer just how fast they can type out a function. Which means if you are a time-poor developer trying to keep up without being overwhelmed by clutter, you really need to look under the hood of these trends.
Spot on. You cannot just skim the headlines anymore.
Exactly. So let us pull apart what happens when we let machines write our code. We are going to explore how it is literally breaking our infrastructure and why human design is suddenly more critical than ever.
I reckon the first massive shift we need to unpack is this concept the community is calling the cult of vibe coding.
Oh, I love that term. It perfectly captures this bizarre behavior where developers are just entirely avoiding inspecting their source code.
Yeah, they are treating their entire project as a complete black box. They type a prompt into an agent, they wait for it to generate the application, and if it looks visually correct on the screen, they just ship it to production.
Wow. They never read the underlying logic at all.
Not a single line. And the danger of that approach is the abstraction layer becomes so incredibly thick that developers are completely divorced from the execution of their own programs.
It is like letting an overly enthusiastic teenager build a house just because they swing a hammer really fast. You get a house, but the plumbing empties into the ceiling.
That is exactly it. When you generate code via a pure prompt without reading the output, you are basically taking out a high-interest loan on your technical debt. When that code eventually breaks, you have absolutely zero mental model of how the system routes data or handles memory.
It treats code like a disposable paper cup instead of the actual foundation of your business. And the sheer volume of tools pushing us toward this behavior is just staggering. I spotted this cheeky observation in the material that Microsoft has 80 distinct products, all named Copilot.
Wait, 80?
80. It is like they are slapping the name on everything from code editors to spreadsheets, just hoping the machine will do the heavy lifting for us.
That is wild. And the psychological impact of relying on those 80 copilots is pretty profound. There is this fascinating academic model exploring the shift, comparing two hypothetical researchers, Alice and Bob.
Ah, yes, the classic Alice and Bob.
Always. So Alice tackles complex programming problems herself. She writes the code, she hits roadblocks, she stares at error logs for hours. Through that painful friction, she builds deep intuition.
Right, she understands the mechanical failure points of her system.
Exactly. She knows exactly how the memory is allocated. Whereas Bob, well, Bob just wants to go home at 5 o'clock.
Fair enough, honestly.
Sure, but he delegates all that friction to a language model. The immediate output looks identical to what Alice built. Bob gets the result, but he completely misses out on the neuroplasticity of problem solving.
So he experiences this slow, comfortable drift into total technical ignorance.
Yes, spot on. When his server goes down, Bob is essentially a passenger in a crashing plane. He has no idea how to take the controls.
Which brings up the legal ramifications of Bob and his crashing plane, because that is a massive point of contention in the open source community right now, especially regarding the developer certificate of origin.
Right, the legal mechanism where developers certify they have the intellectual property rights to submit code to a public repository.
Because the legal liability does not just vanish when you use an artificial intelligence. I mean, you cannot sue a language model when it inevitably plagiarizes a proprietary algorithm or introduces a fatal memory leak.
No, you absolutely cannot. Someone still has to sign their name to the open source pull request and take the blame.
Which is why the consensus reached in the Node.js community is so interesting. They ruled that machine-generated code is only acceptable if a human contributor takes full responsibility for reviewing and understanding every single line.
Yeah, you cannot blindly submit 1,000 lines of generated code anymore. The human remains the sole point of accountability.
You have to own the logic even if you did not type the characters, which makes absolute sense. You own the code, you own the crash.
Exactly. But, you know, our brains are not the only things getting lazy or overloaded here.
What do you mean?
Well, the agents themselves are literally breaking the physical tools we use to build software. There is a statistic showing GitHub availability drastically dropping to 90%.
Wait, 90%. For a platform that underpins the entire global software ecosystem, a 10% drop in availability is catastrophic.
It is massive. It means the servers are practically crumbling under the weight of traffic, and the core culprit is not human engineers just mashing the refresh button.
Let me guess. The core culprit is relentless machine traffic.
Spot on. An autonomous coding agent does not just write a block of code and go grab a coffee. It operates on an automated agent loop.
Right, so the physical architecture of that loop is this continuous cycle of reasoning, then calling a tool, then checking the result and repeating.
Exactly. It is essentially a massive automated while loop just hammering the infrastructure 50 times a minute. It writes the code, it checks the terminal, gets an error, rewrites the code, and checks again.
And the physical mechanism behind that loop operates at the speed of compute. A human developer runs a test and pauses to think. An agent loop fires off dozens of requests a second.
And this massive synthetic load just saturates databases. It completely overwhelms Redis clusters.
Which are the high-speed in-memory data stores designed to cache information for quick access.
Yeah, and when an agent loop goes berserk, it fills that cache with garbage queries until a cluster panics. It even stresses out failover mechanisms because those backup systems were designed for human-scale traffic spikes.
It's not relentless robotic hammering. So we basically built development tools so incredibly fast, they are accidentally launching distributed denial-of-service attacks against our own version control system.
Yeah, we're essentially self-destructing our own infrastructure just to generate boilerplate code.
Which, yeah, is exactly as terrifying as it sounds. But hang on, the servers are failing, but are the artificial intelligence models failing right alongside them?
Oh, absolutely. Developers are actively breaking the models by expecting them to hold too much information at once. We are running hard into the mathematical limits of context windows.
Because if you are a developer listening to this, you have probably thought, hey, if I want the machine to write perfect code, I should just feed it my entire repository.
Or just give it all context.
Yeah, give it the documentation, the commit history, the old Jira tickets, just stuff it all into the prompt and let it figure things out.
But that assumption fundamentally misunderstands how language models process information. A context window is basically the short-term memory of the model.
So it dictates the exact number of tokens or word fragments the model can hold in its active memory.
Exactly. And a major Chroma study revealed that as you stuff more tokens into that window, accuracy does not increase. It actually plummets from 95% down to 60%.
Oh, wow. So more information actively makes the machine stupider. It is like trying to find your car keys while someone screams the entire plot of a movie at you. The extra clutter actively degrades the signal.
That is a perfect analogy. The underlying mathematical reason for that degradation is the attention mechanism within the neural network. Calculating attention has a quadratic cost.
Right, so every new word you add has to be mathematically weighed against every single other word in the prompt to understand the context.
Spot on. So when you dump an entire code base into the prompt, the matrix multiplications become so incredibly dense, the model just hallucinates or loses track of the core instruction. It suffers from severe cognitive overload.
Which forces developers into this practice of context engineering. Instead of giving the model a massive, messy brain dump, they are building external memory systems to feed the agent only what it needs at the exact millisecond it needs it.
Yeah, like this fascinating project called hippomemory.
Hippomemory, what is that?
It takes a brilliant biological approach to solving this compute problem. It mimics the human hippocampus. Our brains do not remember every single thing we see. We survive by implementing memory decay and memory consolidation.
Oh, that is clever. So hippomemory applies that exact biological principle to a vector database.
Yes, it intelligently identifies older irrelevant context vectors and mathematically prunes them. It forces the agent to forget.
Wait, so we are essentially teaching supercomputers how to forget things so they can think clearer.
Exactly. It consolidates only the highest value information, keeping the agent sharp and focused without overwhelming the mathematical limits of the context window.
That is brilliant. And speaking of the bizarre lengths developers are going to, in order to optimize these machines, this brings me to something that had me genuinely laughing out loud. The Caveman plugin.
Or the Caveman plugin is pure pragmatic engineering. It's basically born out of financial necessity.
Because when large language models communicate either with the human user or with other autonomous agent subsystems, they are heavily trained to be polite, right?
Very polite. They use vast amounts of conversational padding. They generate phrases like, certainly I can assist you with that right away, and here is the updated function you requested. Please let me know if you need anything else.
Which is very lovely and polite, but absolutely useless when two machines are just passing JSON files back and forth. I mean, you do not need pleasantries when you're talking to a server.
Not at all. And the problem is every single letter of those pleasantries consumes a token. And generating tokens requires massive matrix multiplications on very expensive graphics processing units.
So politeness literally costs compute time, energy, and real-world money.
Exactly. So the Caveman plugin intercepts that communication, strips out every single filler word, and forces the agent into an ultra-compressed communication style.
Wait, so we are literally forcing advanced supercomputers to speak like cavemen to save money. Just grunting technical syntax at each other because saying please and thank you is too expensive on the cloud hosting bill.
Yeah, because apparently that is where we are now. It maintains total technical accuracy, but it delivers the raw syntax and nothing else.
That is hilarious. And how much does it actually save?
It cuts token usage by an average of 65%.
Oh, wow. 65% is massive.
It is huge.
Yeah.
That translates directly into lightning-fast response times and drastically reduced running costs. But compression is only one half of the optimization equation.
Wait, what are the other half?
The structural quality of the code the agents are reading in the first place. Clean, modular, human-readable code is more critical now than ever before.
Because if your repository is a tangled mess of spaghetti code, the agent is going to burn through its context window just trying to figure out what your variables mean.
Exactly. It is the ultimate expression of garbage in, garbage out.
It reminds me of that legendary story of Bill Atkinson from the early days of Apple. Management was tracking developer productivity by counting the lines of code they wrote.
Right. The old assumption that more lines meant more value.
Yeah. So Atkinson spent an entire week optimizing a graphics program, finding this elegant mathematical solution that allowed him to delete massive chunks of messy, redundant code.
Making the system much faster and far more stable.
Exactly. So when he filled out his productivity form, he reported negative 2,000 lines of code. He proved mathematically that removing unnecessary complexity is the true mark of brilliant engineering.
And that principle holds up today. Keeping code structurally simple prevents that cognitive overload for agents trying to parse it. But some developers are taking a totally different route.
Okay, what are they doing instead?
Instead of just compressing the information, they are building auto-research agents.
Auto-research, like doing homework before coding.
Spot on. A standard agent reads your prompt and starts typing immediately. An auto-research agent implements a rigorous literature review phase before writing a single line of code.
So it reads external documentation, it analyzes competing open source repositories, and it studies mathematical approaches to your specific problem.
Yeah, it does a full academic exploration of the problem before it even touches the keyboard.
And is the payoff for that extra homework actually measurable?
Definitely. There's an example of an auto-research agent tasked with optimizing text generation code. By reviewing external literature first, it found a superior mathematical fusion approach, resulting in a 15% increase in CPU inference speed.
Which just means the application processed the data 15% faster than the human-written version.
Exactly. But handing an autonomous agent the ability to scour the internet, read documentation, and write highly optimized code raises a terrifying security double edge.
Right, because we have to consider what happens when these incredibly capable machines start poking around in our legacy systems.
Well, we already know exactly what happens. A security researcher unleashed Claude code on the Linux kernel.
Oh boy.
Yeah. Autonomously, without human prompting, the artificial intelligence uncovered a heap buffer overflow vulnerability in the network file system driver.
Just so we are clear for anyone listening, a heap buffer overflow is essentially when a program tries to stuff too much data into a designated block of memory, causing it to spill over and corrupt adjacent data.
And hackers absolutely love exploiting that because it lets them overwrite critical system commands.
And the machine found this entirely on its own.
Entirely on its own. This specific vulnerability had been sitting hidden in the open source Linux kernel for 23 years.
23 years. A decades-old flaw that countless human security experts and automated scanning tools just completely failed to spot.
Yeah. The reasoning capabilities of the agent found the missing bounds check immediately because it can hold the entire execution path in its memory at once.
Which is fantastic for defensive engineering. We can patch things humans missed. But let us elevate this to the more aggressive side. I want to get into Project Glasswing and the Claude Mythos preview.
Ah, yes, Project Glasswing. This is a major industry initiative using the Claude Mythos preview to secure critical global software. This model does not just find old bugs.
What else does it do?
It autonomously discovers entirely new zero-day vulnerabilities across critical infrastructure, and then it writes the complex exploits for them.
What, it writes the actual weaponized payload.
Yes, it figures out the attack vector and writes the exploit code. That used to take a team of highly skilled cybersecurity experts weeks or months to engineer in a secure lab.
And the artificial intelligence just maps the architecture and generates the exploit in a fraction of the time.
It proves the vulnerability is real by successfully exploiting it in a sandbox.
But if a machine can write a complex zero-day exploit in 5 minutes, are we not just handing a loaded weapon to the open internet?
That is the big concern. When bad actors build their own agent loops, we are going to see an avalanche of automated attacks.
The security industry must be terrified.
They recognize it is an automated arms race now. Defenders can no longer rely on obscurity or slow corporate patch cycles.
Because if adversaries use autonomous reasoning loops to find holes, the only possible defense is using defensive artificial intelligence to find and patch those vulnerabilities faster than the attackers can exploit them.
Precisely. The speed of the patch cycle has to match the speed of the compute.
Which brings us perfectly to the core reality of all this. From the mirage of vibe coding to server collapsing agent loops and automated zero-day exploits, there is one undeniable conclusion we have to draw here. Human architecture is king.
Absolutely.
There is a quote I found incredibly grounding amidst all this hype. Claude is not your architect.
That is such a crucial point. Language models, by their mathematical nature, are agreeable pattern matchers. They are heavily trained to give you the most statistically probable, helpful answer to your prompt.
Right, they just want to say yes. But a true architect has to say no.
Spot on. A human architect understands the specific constraints of the business, the budget limitations, the team dynamics, and the long-term maintenance burden.
And an artificial intelligence will just output a perfectly formatted, highly generic system design that completely ignores the messy reality of your specific engineering environment.
Because it cannot take ownership of risk.
Exactly. When the database locks up at 3 in the morning, you cannot page the language model to join the incident response call. You need a human who understands the blast radius. Good human architecture looks entirely different when machines are writing the code.
Look at Spotify as the absolute gold standard for human-led system design. Spotify maintains an astonishing 95% success rate for regular releases.
That is incredible at their scale.
Right. They roll out continuous updates to 675 million global users without breaking the application. And they achieve that through a meticulous architectural concept called rings of exposure combined with strict feature flags.
A feature flag is essentially a digital toggle switch wrapped around new code. The code gets deployed to the live production servers, but the toggle is set to off.
So the code is sitting there dormant. No user can see it or interact with it.
It completely decouples code deployment from feature release.
Exactly. The human architects then take control of the exposure. They turn the feature flag on for a tiny inner ring, perhaps just the internal quality assurance team.
And they monitor the error logs.
Right. If the metrics remain stable, they expand the ring of exposure to 1% of live users, then 10%, then 100%.
And if the agent-generated code suddenly causes memory usage to spike or crashes the payment gateway, the human engineer does not have to perform a massive frantic server rollback.
They just flip the feature flag back to off.
The broken code is instantly deactivated for all users without touching the underlying deployment pipeline. It is a brilliant masterclass in risk mitigation.
It proves that the value of a developer is shifting away from typing syntax. The typing is cheap. System design, risk management, and architectural verification are priceless.
It's the difference between writing a recipe and designing the whole restaurant kitchen. The machine can act as the sous chef. It can chop the onions, it can prep the sauces, and it can write the boilerplate faster than we ever could.
But you absolutely need a human head chef to design the workflow, manage the risks, and make sure the kitchen does not catch fire when the dinner rush hits.
We have pulled apart a massive amount of material here. From the dangers of vibe coding and broken infrastructure to caveman plugins and zero-day exploits. But I want to leave you with a final provocative thought about the future of your role as a developer. If artificial intelligence is taking over the typing and the code generation, what is the one uniquely human skill you're going to master next to make sure you are designing the kitchen and not just chopping the onions? Something to mull over while you review your next pull request. Thank you so much for exploring the material with us. There's always more to unpack on vocal technologists, so keep questioning the automation. Catch you next time.
Spoken Tech, for your ears.